Okay, so welcome to Chapter 4, Section 4. We're going to take a closer look at testing. We're going to see what can go right and what can go wrong. So it turns out when we perform a hypothesis test, there are 4 things that could happen. I'm going to arrange them in a nice table. So up top we have the decision we make. We learned last time that we can say one of 2 things. We can say we reject the null, or we can say we fail to reject the null. So those are our 2 possible decisions. On the left, I've got the truth. So the truth is either the null hypothesis is true, or the null hypothesis is false. Now, we might not actually know the truth. In fact, we probably don't know the truth, but that doesn't mean the truth isn't there. So don't get too hung up on that. If I reject the null when the null is false, I have made the correct decision. Things are good. Similarly, if I fail to reject the null when the null is true, I've again made the correct decision. But what if I reject the null when the null is true? Well, I've made a mistake, and that mistake has a name. It's called the type 1 error. Similarly, if I fail to reject the null when it is false, I've made another mistake. That one is called a type 2 error. So this is a nice table that shows you what all could happen in a hypothesis test. We can define type 1 and type 2 error formally, so they are vocab words. So a type 1 error, that is rejecting a true null. A type 2 error is failing to reject a false null. And we've got a nice picture here to help us remember. So type 1 error is also called a false positive. A type 2 error is also called a false negative. So this is a nice joke to help you remember. And a lot of times the example that you see people use here is a court of law example. So we're going to use that too. So in a court of law, a person is innocent until proven guilty. So innocent, that's our null. Guilty, that's our alternative. And in order to say someone is guilty, evidence must be beyond the shadow of a doubt. Evidence for us is a p-value. Beyond the shadow of a doubt is less than alpha. So that was our definition for statistically significant. Now, there could be some mistakes made here. You could convict an innocent person. That would be making a type 1 error. So you rejected the null when in fact it was true. You said the person was guilty, but they were innocent. Or you could release a guilty person. So that's a type 2 error. We failed to reject a false null. So we said they were innocent, but they really weren't. The probability of a type 1 error is alpha. Now you might recognize alpha. That is the same alpha as our significance level. So this is something we know, and it's something we can control. That's why we set alpha at a level that we are okay with. So that's why we usually pick something like 1% or 5%, and you would not pick something like 40 or 50%. Type 2 error, the probability of that is beta. Now unfortunately, we have no idea what beta is. This is something that we don't know. This is something we can't control. So, question. In the last section, I told you we don't accept the null hypothesis. We don't say that. We worked through our elephant example. Now we want to think about, theoretically, why don't we say this? It's because we don't know the probability of being wrong. We don't know the probability of making a type 2 error, so we don't want to go around accepting the null. That would be too strong of language for that situation. We're only okay with saying we fail to reject. Okay, well, if we can't accept it, why can we reject it? Because we do know the probability of a type 1 error. We set that at something we're comfortable with. We're really willing to take the risk there. There's also something called the power of the test. So the definition of that is the probability of rejecting a false null. In other words, it's the probability of your test being correct in a specific way. And there is a relationship. So power is equal to 1 minus beta. Now, we're not actually going to use this to calculate any numbers. So if I ever ask you what is the power of the test, I'm not looking for something like, oh, it's 0.87. I'm looking for the definition in context. Now, in general, our goal here is we want to perform a hypothesis test that controls for alpha. What that means is you set alpha at the very beginning before you start doing the test, and at the end, when the test is done, you want alpha to still be at the level that you set. There are certain situations where if you use the wrong test, you might think you had a 5% chance of making a type 1 error, but by the time things are all said and done, you might have a 25% chance of making a type 1 error. So we want to make sure our test doesn't do that. We also want to maximize power. So we said we don't know beta, but we do know power, sort of, and if power is high, that means beta is going to be low because of the relationship up at the top of the slide. Again, you will not be calculating any numbers for beta or power. We only show the formula so that we know the relationship. And it turns out that a nice way to maximize power is actually having a larger sample size. There are limitations to that we'll discuss later, but it is a good way to get ourselves more power. So we'll work through an example. This is a typical example that you might see on a homework or on an exam. I really like these questions. I think they're fun. They're kind of like puzzles. So consider the following hypotheses. Our null hypothesis is that it is snowing. The alternative hypothesis is that it's not snowing. So I want to know, first question, in context, what is a type 1 error? Well, remember what it is out of context. Out of context, a type 1 error is when you reject a true null. So in this situation, if I reject the null, that means I'm going to say it's not snowing. And if the null is true, that means the reality is that it is snowing. So putting those two pieces together, making a type 1 error is concluding it is not snowing when in reality it is snowing. Okay, what about type 2 error? Remember, out of context, that is failing to reject a false null. So if I fail to reject, that means I say it's snowing. And if the null is false, that means in reality it's not snowing. Put those two together, we conclude it is snowing when in reality it is not. And never mind. Won't make this more complicated. So, lastly, what about the power? Now this is probably the trickiest part of the three. So, remember the power was the probability of rejecting a false null. So if I reject, I say it's not snowing. If the null is false, that means the reality is it's not snowing. So the first way you can write this is the probability of concluding it is not snowing when in reality it is not snowing. Basically, you've made the right decision in a specific way. Important part here is you have to start with the probability of. The power is a probability, it's not a decision. That's kind of a weird way to word things, so there's another option. You could say the probability of correctly concluding that it is not snowing. So that's another variation on the wording there. And that wraps up section 4.4 for us. So that was a short one. I'll post some questions about this. See you next time.